Good evening, everyone. Am I audible to you guys? Can you hear me? Okay. So, good evening, everyone. I'm Shefali Agarwal, and this is our 10th TA session on the topic of basic construction material. So, for this 10th week, you might have studied about different pavement materials. So, the outline of week 10 will be we have talked about different type of payments. What are the different important pavement materials? Mainly, we will talk about bituminous material and what are the different testers of bituminous material, then asphalt, concrete, and also we'll talk about concrete pavement. And other thing is what are the typical cross sectional of both asphalt concrete and concrete pavement, and what are the different modes of failures in asphalt concrete and how asphalt concrete can be recycled. Same way we will talk about the different concrete pavements. Okay, so and little overview, what are the different types of pavement we have. Firstly, we have a broad classification of flexible and rigid pavement. So if you can see from this diagram, in flexible pavement we will usually use asphalt or bitumen, and in a rigid pavement we will use a normal concrete slab which can be reinforced or cannot be reinforced. Otherwise all other layers will be same. We have soil as a subgrade, then we will put some stones for sub base, and again this sub base can be made of all the coarse aggregates, or it can have fine aggregates, or it can have sand to it. And then we have if we talk about flexible pavement, we have base course, then we have surface course, and then surface dressing. So normally we are using in India we use charcoal as a surface dressing. Base course will be aggregate and asphalt, and the surface course will be mostly asphalt or bituminous. And in case of rigid pavement, we don't have all these three things. We have just a concrete slab, and the other thing in concrete slab can be reinforcement. There can be fibers to it, concrete slab, or some joints in between two slabs. So those are the different type of rigid pavements. So this is a broad classification. Other than these two type of pavements, we have a macadam type of pavement. So that is a type of it can be in flexible or rigid. So what is the main difference between these two type of pavement is wet mix macadam and water bound macadam. So in wet mix macadam, before pouring the surface layer, we have a mixture of aggregates means fine aggregates, sand and water will be a base. And in water bound macadam, we have only the coarse aggregates which are interlocked with each other. What is the main use of this type of layer is whenever there is rain or something, water will penetrate through this and will go to the soil surface below. So next, as we have talked in previous slide, what are the more important materials which we are using in pavements is soil, coarse aggregates, fine aggregates, and then we have asphalt and bitumen and concrete. For concrete, we know the basic material for concrete. So those are the most important pavement material which are being used. So next thing is we will go to the first type of pavement, that is flexible pavement. So in flexible pavement we usually use bituminous materials, and two type of bituminous material which are available are asphalt and tar. So asphalt can be available from the petroleum oil, and tar is coming from the distillation of bituminous coal. So this is a type of natural material and this is a type of man-made material. So in asphalt itself we have three type of pavements. We have asphalt cement pavement, then asphalt cut bed and asphalt immersion pavement. So you need not know about all these three type of pavements. Mainly the focus of this lecture will be on asphalt cement pavement. So this is a normal process how we will get asphalt from petroleum oil. So we are collecting the petroleum and then it is going to the pump station, and from there some distillation will happen, and then we will get different type of residues, and we have light solvents, medium solvents. So these are the, just a minute, 1 minute. Sorry. So we have after distillation we are getting different type of materials. So if we talk about different solvents which we can get, they are divided like light, medium, heavy, which can be like the normally we are using gasoline, diesel, petrol and all those things. So medium will be kerosene, heavy is diesel, and light will be petrol or gasoline. And other than these solvents which are being used usually in our day-to-day life, we have some residues which are mainly our asphalt cement, and then we have all these cut bed, emulsion. If we are adding some solvent or water to it, it will become cut bed and emulsion. And last thing we are getting is different air blown asphalt. Okay, so where all this bituminous material are actually used? One thing we know, in pavements we are using this thing as a top layer. Then in our normal building structure also we are using it as a damping course. So normally if you have seen some old houses and all, on the roofs you will put some asphalt or bitumen, right? Charcoal layer we will pour over our terrace to make it waterproof. So we will put we can use bituminous material as a waterproofing, and we can use it as a damp proofing normally in bathrooms and all outside. What we'll say, under the near foundation itself, when we are putting wall, before that only we will put the these asphalt cements, and they can be used for the flooring material also. So these are the few example where these bituminous materials can be used. So next, coming up to the what are the different type of tests which we are performing to check the properties of our bituminous material. So basically we have three type of tests: ductility test, penetration test and softening point test. So in ductility test, if you can see, we have asphalt and we are just stretching it, and the point this asphalt will break, at that point we will tell that our material is no more, that distance will tell us about the ductility of your asphalt or your material. Next test is about the penetration test. So normally our bitumen or our any bituminous material will have are made of organic compounds, right? What we are doing is we are just checking how much it will penetrate under a particular amount of time. So mainly after 5 seconds, within 5 seconds, how much penetration it is happening of 100 gram of sample will give us about the penetration test. So why these type of tests are important? As we know, our bitumen is viscous material, so it is important to know about its viscosity properties. So normally when we are checking viscosity, we will test, the main important test we are doing is penetration test. Next is the softening point test. So in softening point test, we are increasing the temperature, and with increase in temperature, how our bituminous material is melting. So that we will check from the softening point test. So other than this, we have if we have to do some mechanical testing or some durability testing, so we can do the core cutting from our what will say, from our site, from any road or something. We will do the core cutting, we will take the sample to our lab, and then we will check the different properties of this type of material. So normally we are checking for strength, stability and void structures. So these three are the main tests which we are doing from the cores which are collected from the site. So as we talked about that our bituminous material are mainly organic compounds. So the molecular structure of this material is more important than its chemical composition. So if you see from this example, if your C by H ratio, carbon by hydrogen ratio, is less than 0.4, in that case you have a very good viscosity. However, if it is more than 0.8, then your stiffness and strength will be higher, and in case it is approximately equal to 0.6, your adhesion and ductility will be more. So if you can understand, this is like carbon carbon chain, carbon hydrogen chain. So more the carbon, longer the chain, we can say more will be the C by H ratio. So more the C by H ratio, more will be the strength, unless the C by H ratio will make the material more viscous and fluid. Okay. So as we are talking that our asphalt have a viscoelastic behavior. So what is happening is, with increase in temperature, our viscosity will decrease and our material will become more soft. So if you have observed in roads and all, when during hot climates or during summers, what is happening, your road will bend easily, or it will, you can see some shiny thing, your tar will melt easily. So that's how we can say that when we are increasing the temperature, your material will become more soft and there are chances of rutting. So we will talk about what is rutting. And when our temperature is very low means when our temperature goes like -5 in hilly area mostly. If our temperature is -5 or something, so what will happen, your bitumen will become very brittle. In that case, what will happen, there will be thermal crack. So all this type of cracking or all this type of damages we will see in the next slide. So this is a typical pavement cross section. We have already seen, we have subbase, subbase, base and then surface. However, in case of rigid material, what will happen, this base and surface will be a single unit of concrete pavement. Okay. So how, next thing is laying of asphalt concrete. So how asphalt concrete is being laid. So this is how a typical asphalt concrete look like. We all have seen on roads and all. Normal roads in India look like this only. So this is one procedure. Then on corners, this is another procedure of providing edging and all. So these are the different type of methods how by which we are doing asphalt concreting. So these are the next thing, as we were talking in last slide, what are the different failure mechanism in our asphalt concrete pavements. So first type of damage is stiffening and excessive surface roughness. So why this type of thing is happening? Because of mainly aging. So what is happening, with time your bitumen will become very dry. Okay, it will lose its it will become very low viscous, and it will become very dry, and because of drying, what will happen, it will lose the bonds between the aggregates. So when that bond will be broken, will be loose, that time you can see some cracking in your pavement. So that is the first type of damage in a flexible pavement. Another type of damage is thermal cracking. So as we have seen in previous slide, when the temperature is very low and your bitumen will become very stiff and very brittle, there are chances that your payment will break through laterally. Next thing is we have stripping. Stripping means what is happening if there is a not the bond between sub base and your base is not good, in your surface and sub base is not good. What will happen? Your aggregates and your bitumen will be removed, and there will be a complete hole kind of thing from where you can see the below soil. So that is called as striping. Next is the fatigue cracking. So fatigue cracking means when you have continuous cracking or under creep or under fatigue loading. What normally when you have continuous loading, some cracks will appear onto the surface of your on your pavement surface. Next thing is rutting. So we're talking about rutting. What is happening in rutting? Your pavement will become very soft. So what will happen if it is become very soft? When you are going with when you have excessive loads, your wheel load, it will make a mark into your road surface. So if your wheel have moved in this direction, so there will be a bump, or we can say bump in our road along the wheel line. So that is called as rutting. So these were the main type of damages which we can see in the asphalt pavement. Other thing is recycling of asphalt pavement. So why we need to do recycling of our asphalt pavement? Any idea? So first thing is, normally our concrete recycling, or what you say, our pavement waste, bituminous waste cannot be dumped easily. So it's not like, we know it is coming from the petroleum industry, so it is not good to dump it. So it is better we can recycle it. And second thing is, what is the advantage for pavements and all? We don't need excessive load as compared to our structures, right? So in that case, we can use the old bituminous waste in the new type of pavements itself. So this is a normal recycling procedure for asphalt pavement. So this type of crusher will be used, and it will just stripe off the top surface of your asphalt pavement. Like in this example, you can see it is taking away the top surface of asphalt pavement, and this material can be collected and recycled. So this is all about the flexible pavement. So next thing is the concrete pavement or a rigid pavement. So in concrete pavement or rigid pavement, what we are telling, we are having soil, then we have sub base, and then we have concrete base. So in concrete base, there can be, here we have tie bars, we have double bars, and then we can have normal rebars, and then we have different type of joints. So how we have our concrete slab in normal structure, same way we will have concrete pavements. However, in case of pavements, we have to provide joints, or it can be continuous also. So if we talk about joints, in this case, if you see, we have double pavements. So wherever we are providing joints, we will provide dowels. So it is like a simple rod, and it is provided in a straight way, if you can see in this example, and our concrete is laid in different area like this concrete, and this will provide a expansion joint in between two slabs. We can call it as one slab, two slab. So in between two slabs along the wheel load, it will provide a expansion joint or contraction joint. So that is a double bar. However, tie bar is provided longitudinal to the wheel load. So what is happening? It is in this direction we are providing tie bars. So tie bars will prevent the joint, will provide expansion joint in between two slab perpendicular to the wheel load. Okay, double bars parallel to the wheel load, and tie bars perpendicular to the wheel load. So next thing is, that was the joint pavement. If we other type of pavement is continuously reinforced concrete pavement. In case we don't want to provide rebars at all points, if you can see here, rebars are only provided near the double bars and in the corners. So here only we are providing reinforcement, or many times it won't be provided there also, only joints are provided in the normal concrete slab. And if we are providing our full reinforcement, as in case of our normal what to say building slab, in that case we can provide continuously reinforced concrete pavement without any joint. So these are the different type of rigid pavements. Other thing is, what are the different properties which we are desiring from concrete pavements? It should have good strength, good abrasion resistance, should be crack resistant, mainly shrinkage and warping of slab during high temperature and all, skid resistant, and it should be comfortable. Normally when we are providing joints, there are chances of failure at the point of joints and or uncomfortable ride at point of joints, and so it is good to have a comfortable rigid pavements. So in rigid pavement itself, further at the top surface we will do the surfacing procedure. Why we are doing surfacing? Like in this case they are using broom to provide a surface, and in this this case this is called as tining. This is called as tining. So why we are providing this thing? Mainly to have a skid resistance property of our concrete pavement. So that's what you might have studied in this week 10. If you have any doubt, you can ask me now, otherwise we will go to question and answer session. If there are no doubts, then we will see few questions. First question is, in asphalt pavement, you can give the answer in chat box or you can speak also in between. In asphalt pavement, the load intensity of the top layer is dash than that on the bottom layer. Is same as the bottom layer, lesser than the bottom layer, higher than the bottom layer. You have a question. What are the advantages of rigid pavement? So advantage of rigid pavement is, firstly, it will be more durable than our flexible pavement. Okay, and it can bear more load. So mainly if you are providing highways and all, national highways, at that point we cannot provide flexible pavements. So for that kind of pavements we need some load bearing, or because we need in that area high speed is required. In that case we will provide rigid pavement or concrete pavement. Okay. So if you see in rigid pavement, normally what is happening, there is a pressure which will directly go from top to bottom. So load will be more on top layer and then it will be distributed like it will be distributed till the bottom layer in a negative way. Okay, so the load intensity of top layer will be more than that of bottom layer. Okay, so load distribution in case of asphalt pavement will be in this case, like higher to lower. In case of concrete pavement, what will happen, your base or sub base will be made of aggregates and soil, so that will have a more load intensity, or load distribution will be like uniform kind of thing. Whereas in flexible pavement, your top layer will carry maximum load and next layer less. So that's why the intensity of top layer will be more than that of bottom layer. Okay, so second question is, what is or are the primary difference between WBM and WMM payments? Water bound macadam and wet mix macadam payments. So WBM uses dry aggregates, WMM uses wet mix aggregate. WBM uses bituminous binder, WMM uses cement. WBM has a lower strength than WMM. Anybody who want to guess the answer? So as we have seen in first or second slide, A and C. Okay. So A and C are the correct answers. In water bound macadam, we are using our dry aggregates or coarse aggregate as a bottom layer, and above that we are laying the what we say base layer. And in water mix macadam, we are using mix aggregate, a small aggregate, large aggregate, and that will be, and above that we are providing our base. And other thing is, we are not using bituminous binder, otherwise it will penetrate, it won't let water penetrate through the base to the aggregates. And water bound macadam has a lower strength, obviously, since we are using only coarse aggregate and there is no good bond between the layers, so it will have a lower strength than WMM. Okay, so next question is, in WBM roads, which factor is the most crucial factor for ensuring stability under heavy traffic loading? Using of bituminous sealing coat, proper interlocking of coarse aggregate, addition of chemical stabilizer, high water content in mix. B. Correct. So as in previous question itself, we saw that we are not using the bitumen in WBM rod, and also we won't use any chemical stabilizer, and since we are just using aggregate, so there won't be any water content in the mix. So B is the correct answer. Next question is, heating of asphalt is done to reduce viscosity, increase viscosity, or reduce brittleness? So if we are increasing temperature, what A, correct answer. So if you remember that graph, with increase in temperature our viscosity was decreasing. So everyone have given correct answer, will be A, reduce viscosity. So next question is, which of the following layers is not a part of typical flexible pavement structure? Subgrade, base course, wearing course, or expansion joint? This is a very simple question. D, correct. Right. So we won't provide expansion joint in case of flexible pavement. Tar can be used as sealing layer on road surface. Why? Because it does not dissolve in organic solvent, it does not wear and tear easily, it has high strength and ductility. A, okay. Anybody else who want to guess the answer? Okay, yeah. So A is the correct answer, since tar is not dissolvable in organic solvent, we will use it as a sealing agent at the top surface. A, everyone, correct answer. Okay. So the primary function of the bituminous binder in flexible pavement is to provide tensile strength to the pavement, bind aggregates together and provide waterproofing, improve subgrade bearing capacity, or act as a thermal insulator. B. Bind aggregates together and provide waterproofing. Correct. So answer B is correct answer. So normally we are providing bitumen to bind the different aggregates together, and it will provide the waterproofing from the rainwater. Which type of distress in flexible pavements is caused due to repeated loading and fatigue failure of asphalt layer? Rutting, alligator cracking, bleeding or reveling? A. Okay. So normally when if you remember in our slide when we were talking about different type of failure, in fatigue failure or in repeated loading, this is the type of cracks we have seen, right? So this type of crack will are corresponding to alligator cracking. Okay. Why rutting is not an answer? So if you remember, we talked about when temperature is very high. In that case, when we have excessive wheel loads, there will be a bend in our surface, that is called as rutting. Okay. In case of fatigue failure, there will be alligator type of cracking. Is it clear? Okay, so the next question is, what is the main cause of rutting in flexible pavement? Poor subgrade support, sorry, excessive bitumen content, plastic deformation of the asphalt layer, or low traffic volume. So if you remember in last slide I was telling when temperature increases, in that case our bitumen will soften and there are bending or wheel marks will be there on the road, that is called as rutting. So if you see from these four examples, what is happening when temperature is increasing, there is a plastic deformation of your asphalt layer. So the answer will be C. Okay. Okay. So the next question is, in the context of flexible pavement failure, striping refers to, so which type of failure is stripping? Loss of surface texture, separation of bitumen from aggregate due to moisture, formation of rutting due to traffic load, cracking caused by temperature fluctuation. Okay, B, separation of bitumen from aggregate due to moisture. B, yeah, correct answer. So this is a type of stripping failure. Your top layer is completely separated from bottom layer due to the accumulation of moisture in between. Okay. So 11th question is, a bitumen sample with low ductility is likely to resist temperature variation effectively, crack under repeated traffic loads, be more durable in flexible pavement, or have high adhesive strength. So we talked about ductility test. So this was a ductility test. So if your ductility value is very low, if this value is very low, what does that symbolize? That it is resisting temperature variation effectively. Under repeated load it will crack, it will be more durable in flexible pavement, or have high adhesive strength. Crack under typical, correct. So B will be correct answer. Okay. So the next question is, the softening point of bitumen is defined as the temperature at which bitumen melts completely, it starts losing its viscosity. A steel ball placed on the bitumen sample falls through a standard distance, the bitumen starts evaporating. So if you remember that test procedure of our softening point, so we are telling this is our bitumen block or something, and we are keeping a steel ball above it, and when it will melt fully, what will happen, this will fall, and a particular distance at which it will fall along with bitumen, this steel ball is covered with bitumen, sorry, at particular temperature at which it will fall, that is defined as the softening point of our aggregate. So everyone have given the right answer. C is the correct answer. Okay, so the next question is, the viscoelastic behavior of asphalt is dependent on temperature and loading time, only temperature, only traffic load, or aggregate gradation. So from this graph you can tell that viscoelastic behavior is only dependent on the temperature. However, if you see that creep graph, I don't have that graph here. So in creep graph, if you see, when you are increasing your loading time, at that time also your viscoelasticity will increase. Sorry, it will decrease. With increase in loading time, what will happen? It will become more hard, and it will be negative effect. Instead of like this, it will go like this. Okay, so answer will be A. So next question is, which test is most suitable for evaluating the rutting resistance of asphalt mixes? Indirect tensile strength test, creep compliance test, bending beam rheometer test, or wheel tracking test? So I don't think you guys have studied about all this type of tests. So from the type of failure, if we see, what we are telling, rutting will be when we have increased the temperature, and at that point, because of wheel load, there is a bend in your surface. So which type of test from the here you can see, it is not telling about its tensile strength, it is not telling about its creep or under continuous load how it is behaving, or it is not telling about its viscosity to test the rheometry. So the only option is we can use a wheel tracking test. So this is how a normal wheel tracking test look like. So this is an asphalt slab they are using, and providing a different type of loading using this wheel, they will check the rutting depth in the case in the asphalt slab. Okay, so that is a type of test we are using to check the rutting resistance of our mixture. So next question is, can you mute yourself? Yeah. So in rigid pavements, the load is distributed through grain to grain transfer, layered system action, slab action, or flexible action. So if you remember, in the first question we have seen, sorry, this is a rigid pavement and this is a flexible pavement. In term of flexible pavement, load distribution was in this way, and in our rigid pavements, load distribution was in this way. So if you see from this example, in case of rigid pavement, our load distribution is through slab action. C, correct. Next question is, the main reason for providing joints in rigid pavement is to improve the skid resistance, reduce the construction cost, control cracking. You have any question? Somebody raised the hand recently. You can unmute yourself and speak if you have any question.
No.
Okay. So the main reason for providing joints in rigid pavement is to improve skid resistance, reduce the construction cost, control cracking due to temperature and shrinkage, or allow water to drain easily. C. Okay. So that's the correct answer. So we are providing joints between two slabs. So it is normally we are providing expansion joint, so that during increase in temperature or during shrinkage there is no cracking in between two slabs. So at that point we are providing joints. So reflectivity is better in asphalt pavement or concrete pavement? So which type of pavement is more reflective, mainly in night and all, if you have experienced it? So cement concrete pavement is more reflective as compared to asphalt pavement, because in asphalt pavement you can see aggregates and bitumen at the top surface itself. In cement concrete pavement it will be like a plain surface, so it will have more reflectivity as compared to asphalt pavement. Okay. The primary purpose of tinning in cement concrete pavement is to improve structure strength, enhance drainage and reduce hydroplaning, reduce noise and improve skid resistance, prevent pavement cracking. So we are making our concrete surface, or we are making our rigid pavement surface more more rough. Why we are doing it? So that we can improve the skid resistance and reduce the noise. So this is how tinning is done, some layer if you can see. So it is done to provide skid resistance mainly. So the primary reason for providing a tie bar in longitudinal joint of a rigid pavement is to allow expansion and contraction of the pavement, transfer wheel loads across the joint, hold adjacent slab together and prevent joint widening, reduce flexure stresses in slab. So we talk about two type of joints, tie bars and double bars. A, okay. A, allow expansion and contraction of the joint. So if you remember, if this is our one slab, this is another slab, and same way we have slab here and here. So at this joint we are providing double bars, and at this point we are providing our tie bars. So in case of double bars, what is happening? When there is a wheel load, there are chances, wheel load or increase in temperature or something, there are chances of expansion or contraction. Actually A is the correct answer for both. We are allowing expansion and contraction of the pavement using both double bars and tie bars. But here we are asking the primary reason for providing only tie bars. So the main reason for providing tie bars is when this is the road and tie bars are provided here. So it is mainly to hold the two slabs together and prevent the joint widening. Okay. So this is also an correct answer. So we can say A and C both are the correct answer in this case. So I will just correct the PPT and share that. So the last question is, the major advantage of continuously reinforced concrete pavement over jointed concrete pavement is elimination of joint, leading to reduced maintenance and longer pavement life, lower initial construction cost compared to JCP, reduced steel reinforcement requirement compared to JCP, increased flexibility similar to flexible pavement. So this is actually a wrong option, because more steel reinforcement we are providing in continuous reinforcement concrete pavement. So out of these three options, what is the main advantage of this reinforced pavement is A, it will eliminate the joints. Correct answer. So that's all for week 10. If you guys have any doubt, you can ask me now. Week 9, question 3 and 4. You're talking about the assignment, or just 1 minute, I will open the assignment. Straight, true or false? Thermoplastic polymers usually show high creep, and it is a major problem in polymeric materials. Answer, true answer. You have any doubt, or you want me to discuss how it is true? So if you remember, we talked about two type of materials are there, thermoplastic and thermosetting. So in thermoplastic material, what is happening when we are increasing load or something, the bonds will break, and then when we are releasing loads, the it will come back to elastic elastic state. So take an example of normal rubber band. You are stretching it, then you are taking it back, stretching it and bringing it back. So at one point of time, what is happening, if you keep your rubber band at if you use your rubber band for some particular reason, and you have stretched it at a certain load at a certain point for a particular time, so what will happen, your rubber band will become very weak, it will become brittle kind of thing, right? So because of that, actually it have a higher creep value, it can sustain more load as compared to a thermosetting material. Thermosetting material, what will happen, if you will stretch it, it will just break. In case of like plastics and all, bakelite type of plastic, if you stretch it, it will break. However, in rubbers, it can go up to a higher creep value, but because of this high creep value, what will happen, at certain point of time, it will just suddenly break. So that's why we are saying that the higher creep value in thermoplastic polymers is a major problem in polymeric material. Okay. Just 1 minute. First, question number 4. B is also correct answer. Okay, great. The figure given below shows the specific volume, also temperature of materials A, B and C. Select the appropriate answer from the following option. A is amorphous and network polymer, B is semicrystalline, C is crystalline, and A is amorphous and linear. You are telling question B can also be corrected. Semicrystalline and reticulated polymer. But this B graph is mainly for the semicrystalline material, not for the reticulated polymers. So that's why, that's the catch in this question. It's correct for semicrystalline polymers, but it is not for the reticulated polymers. So reticulated means those network type of polymers we have seen in last lecture now. Some where we are forming complete networks kind of thing, what to say, so they are mainly crystalline in nature. If you benzene kind of structure, yeah, some hexagonal benzene type of structure if you have, that is called as the reticulated polymer. So that's why they won't show this B type of thing, they won't have this glass transition temperature. So that's why this option is incorrect. Okay. Okay, so you are asking in question number 1. Arrange the following polymer configuration in decreasing order of strength. Third option, linear branch. Okay, so I think there is something wrong with the question. If you are talking about decreasing order, the sign should be in this way. Sorry, sign should be in this way instead of this way. That's why you got confused. The sign should be less greater than, and they are using less than sign. Okay, I will discuss it, this first question. Because of sign, maybe you might have used the third option. So mainly when we are talking about decreasing order, we should use this less greater than sign, sorry, less than sign. It should be go like this. So okay, I will discuss with this question whether in discussion forum, then I will see if we can correct it. Okay. Any other question you have doubt? Sorry. So if there are no doubts, then shall I close the class? Okay, in case of no more doubts, I will close the class for today. Thank you all for joining.